Hello everyone, my name is Siddharth Mahendra. I'm a Wyzant tutor. Uh, ex- uh, my expertise is electrical engineering, electromagnetic field theory, mathematics, and physics. So, for solving this problem, we have been asked if the circuit can be reduced to a single resistor connected to the batteries. We can do that by finding the equivalent circuit of the initial circuit by using the Norton equivalent and the Thevenin equivalent concept iteratively. What I can do is I have modified this circuit to look like this. And then what I'm doing is this branch, I'm converting it into its equivalent Norton equivalent, as you can see over here. This branch, I'm also converting it into its own Norton equivalent, as you can see here. As you can see that the voltage epsilon 1 will become a current source epsilon 1 by R1, and this will be the Norton equivalent resistance. Similarly, in on this branch will get converted to epsilon 2 by R2 current source in parallel with R2, which is the Norton equivalent resistance, and overall in parallel with R3 from the original circuit. Now, this circuit can again be reduced into this circuit by combining these two current sources, and that can be combined as shown here. I'm calling it I equivalent, and these three resistors, as they are in parallel, they can be made into one resistor. I'm calling it R equivalent, which is R1 in parallel with R2 in parallel with R3. The term for this when opened up is R1R2 plus R2R3 plus R3R1 by R1 plus R2 plus R3, as can be seen here. Now this circuit again can be converted into its own. Now this looks like a Norton equivalent circuit, isn't it? I can convert this into a Thevenin equivalent circuit back here. Okay, so when I do that, this is the final circuit that I get, and we have hence solved the first part of the problem, where we have reduced this into single resistor R equivalent of this value, and a single battery of value I equivalent R equivalent, as you can see here. Now the second part of the question asks us to find out what will be the magnitude of the current and its direction in each resistor. So if I assume the direction of the current I1 through this branch is in this direction, the I2 is in this direction. If you do a KCL at this point, you can see that doing a KCL at this point, you can see that the overall current will be I1 plus I2, which is equal to I3, which I3 is the current in this branch. Now, when this current I3 goes here, this has to break back into the original currents I2 for this voltage source and I1 for this voltage source. And that's the reason you can see that I'm saying I3 will be equal to I1 plus I2, and it breaks back into I1 over here and I2 in this branch. So actual direction of the current I1, I2 will be decided based on the values of R1, R2 and epsilon 1, epsilon 2. As we have not been given the values of these variables, we cannot make an exact judgment of what the direction will be. But without loss of generality, please note, without loss of generality, we can always make this assumption. And if the current I1 is not in this direction, it will be opposite, and this I3 will automatically take care of that. So this analysis has been done without loss of any generality, and this is how generally electrical and electronic circuits are analyzed. Hope you like my explanation. Please feel free to touch base with me if you want to learn more about electrical engineering concepts, anything about analog and digital communications, and also about electromagnetic field theory. I would love to work with you. Thank you.